Howdy everybody, and welcome to episode 7. It's finally time that we start discussing the elephant in the room, the thing that most people have been waiting for. Let's discuss LSP. This episode is going to be broken down into many smaller subsections. There's so much to cover with how LSPs work and all of the intricacies that we can't cover all of this in one episode, or else this episode would be at least an hour long. So in this episode, we are going to cover 3 distinct things. The first thing is we are going to discuss the theory, the basics of why LSP exists and what sort of problems it is designed to solve. The second thing we'll look at is how we can quote-unquote enable LSP support within Neovim using the nvim-lspconfig package. And then at the end, we are going to install an LSP using our system package manager, and we are then going to utilize that LSP within Neovim. Then in a completely separate episode, we are going to look into Mason. Mason is going to allow us to automate the installation of LSP servers, and from then on we are going to discuss how to customize your LSP experience and how to make it just a bit nicer for you. So let's start off with the basics. What is LSP and what sort of problems are we trying to solve here? Now, LSP stands for the Language Server Protocol, and what this means is that by definition it is a communication protocol. It's supposed to be some sort of unified message syntax in a way where we can communicate from a client to a server, and no matter what sort of server you have or what sort of client you have, both of these will be able to communicate with each other because they're using the same underlying format for messages. Now, a language server is a server that can take in some input like a file. I'm going to use Rust as an example here. We can send over a Rust file to a language server, and what that language server is going to do is it's going to analyze our Rust file, and it's going to look for many different things inside. For instance, it's going to look for errors in our code. We used an incorrect type somewhere, or we misspelt a variable name. It's going to find errors of that nature. And then on the other side of the spectrum, we have warnings. We have instructions on how to format the file. And then on the other side of the spectrum, we have things like code actions. So for example, you can run a code action and the language server can say, oh, I can generate this function for you, for example, or I can create some basic type definitions for you. So a language server is a tool specifically for programmers. For us who write code, we would love to see warnings and errors about our code. It would be awesome if we could have a language server that does this. Now, the issue that LSP is trying to solve is, imagine you have 5 editors side by side, completely different editors, and they all open up the same Rust document. Back before LSP existed, every single one of those editors would have had to implement their own sort of schema for detecting errors in files and providing code actions and all of that. Everybody had a different way of doing it. But with LSP, if all of those 5 editors implement an LSP client, they can all communicate with the same server, and the same server is going to produce the same sorts of errors, the same sort of warnings. The word server might be a bit confusing to some of you. Does this mean that I'm going to have to connect to the internet? Like, am I sending my code over the internet to some sort of server? No, absolutely not. A server is something that can produce information for other people to consume. That's where the word comes from, right? It's supposed to serve data, but that doesn't mean it's somewhere online on the web. In our case, an LSP server is simply an application that runs on our computer. It's completely local. It runs on our computer, and in our case, Neovim is going to connect to this server and is then going to simply communicate with it. And you may be asking yourself now, what's exactly the difference between treesitter and LSP in that case? So treesitter, as I alluded to in the past episodes and as I explained, is simply a parsing library. It's supposed to take your files and convert them into something meaningful. But the job of an LSP is much more complex and much deeper. Instead of just finding basic errors in your code like, oh, you missed a bracket, or oh, you missed a curly brace, the job of an LSP is to actually look into the semantics of your code. So not just at a surface level, the structure, but it's supposed to look at the behaviors of your code and catch behavioral errors, not syntactical errors. At a basic level, what this means is treesitter at best can only find syntax errors. It can only find, as I said, a missing bracket, a missing curly brace. However, an LSP can find deeper things like a misspelled variable, an unused function, an incorrect type. Its job is to aid you in the development experience. Okay, so fantastic. We have this LSP, this language server protocol, which allows any amount of editors to communicate with a single language server. And that server can then do all of the magic. It can read your code and it can produce errors, produce warnings that the developer can then see in their own text editor instance. This is great, but how does this practically translate over into Neovim? How does this work within Neovim? Similarly to the treesitter implementation, the LSP client implementation has been here the whole time. It's embedded within Neovim. We have to awaken this functionality with the help of something like lspconfig. The job of a LSP client is to be able to communicate with a server, right? That should make sense. What this means is Say you, for example, hover over a function with your cursor and you press go to definition, right? You press a keybind, which takes you to the definition of a function. What the client then does is it recognizes that you're trying to go to the definition, and then it sends a request over to the server, and it asks the server, hey, I have this function, where is the definition of this function? The server then does its magic and it sends back a response saying, oh, it's in this file at this position. And then the LSP client translates that back over to some sort of physical action. In Neovim's case, this means opening up that specific file at that specific line. And that's how go to definition would work. And one last thing left. Every programming language is different, right? So similarly to Treester, which needs a special parser for every single programming language that exists, the same thing goes for LSP. You need a custom LSP server for a specific language. There's a specific LSP server for Rust, a specific LSP server for TypeScript, and the list goes on. So with that theoretical introduction out of the way, let's now hop on over into Neovim and see what we can conjure up with this new information. Okay, so let's open up our beloved Neovim that we've been working on for the past 6 episodes. And the first thing I'd like to show you is that I'm not lying. LSP has been here the whole time. So treesitter was packaged in a table called vim.treesitter. In our case, LSP is packaged in, can you guess it, vim.lsp. So here's the code that would print out the contents of the vim.lsp table. As a recap, vim.print allows us to print complex tables and display what's inside of them, and we need to use this Lua command in order to execute some sort of Lua. This is an operation that you will do quite often, so there is a shorthand for this within Neovim, and that is simply the equals sign command. So I can type equals vim.lsp, and this is the equivalent to what I had earlier. This is the equivalent of running Lua vim.print vim.lsp. I can hit enter, and indeed you can see that the whole client implementation is already here within Neovim without installing any sort of plugins. And if you scroll down a bit, you can see that there's quite a few functions that can operate on buffers. And the job of most of these functions is to provide the default behavior that you would expect from an LSP client. Stuff like hovering over a function, that means displaying its documentation, going to the implementation of a function, renaming a variable. All of this stuff is essentially already implemented and ready to go within Neovim. There's quite a lot in here, and you're not supposed to know any of this. I'm showing you this because I want to show you that all of this stuff isn't magic. All of this stuff has a physical function or an implementation behind the scenes that does the specific thing that we'd like to do. So I'm going to do something in this episode that I don't believe any other tutorial has ever done. We are not going to install any sort of helper libraries. What we're going to do is we are going to set up an LSP server the hard way. We're going to do it the manual way, and hopefully through this you're going to learn a load, and after that, once we do it the manual way, you'll immediately understand why the LSP config plugin exists and why it's supposed to make our life easier, and in what ways it makes our life easier. In order to actually run an LSP server, we need some sort of LSP server to begin with. So the language server that I would like to set up manually in this episode is going to be clangd. Now, clangd is the name of the language server for the C and C++ programming languages. And you might be asking, out of all of the possible languages that we could be installing a language server for, why specifically this one? Well, first of all, it is the easiest for beginners, and here's why. clangd is essentially the best possible implementation of an LSP server. Some LSP servers break the rules of the language server protocol. They kind of do their own little thing, whereas clangd is very, very faithful to the original specification. So there won't be random errors or weird oddities that we would have to handle ourselves manually. Additionally, C is a language almost all of you should know. It's the most basic language that people learn when they start off with computer science. And even if you don't know C, don't worry, we're only going to be writing some very basic programs in order to demonstrate how LSP works. So over at clangd.llvm.org/installation, we have the getting started page for the clangd language server. Now, if you'd like to install clangd permanently on your system, feel free to follow the installing with a package manager guides here. On macOS, it's as simple as brew installing. On Windows, you need to run the installer. On Debian/Ubuntu, you need to run the install command. It's generally very easy to get clangd installed on your system, just so we're all on the same page. And just so there's absolutely no possibility for anything to go wrong, we're going to install the standalone .zip releases. Now, these standalone releases are simply the binaries packaged in a zip file. This means we can download the zip file, to a single location, every single one of us, no matter what operating system we're on, and then we can simply point the Neovim to that binary specifically. And this just ensures that everybody is absolutely on the same page here, and there's no chance that I'm going to get comments saying, oh, this installation method didn't work on my machine. As long as you just get the zip release over here, everything should perfectly work. So select the operating system of your choice. I'm on Linux, so I'm going to hit clangd-linux, and it's asking me to save the file, so let's save it. The next thing that I'm going to do is I'm going to move the zip file over to my home directory. And then what I'm going to do is, in my home directory, I'm going to unzip this zip file into a directory which I'm going to call clangd. At the end of this episode, we are going to remove this zip file. I'm showing you all of this as a demonstration of how the LSP servers work. So we're now going to unzip into the clangd directory, and inside of clangd, I'm going to have a subdirectory called clangd_17.0.3. That's the version that we pulled from the internet. And in here we have a binary folder, so we obviously want to go into that. And inside, here you go, here's the clangd binary. As I said, an LSP server is simply an application that's going to run on our system. So it makes sense that we're going to have a clangd binary over here. I can even go as far as to run this binary itself. And upon hitting enter, you can see clangd gives us a nice warning saying that it should be used via an editor plugin rather than being invoked directly. But what I'm trying to show you is that this is an application that we can run just like anything else. So I'm going to press Ctrl+C to now terminate the language server. And what we now want to do is we now want to point Neovim to this language server. We want to say, I want you to use this for my C files. Now to do this, we are going to use the vim.lsp.start function. This creates a new LSP client and starts a language server of our choice. If you're opening the help pages and for some reason you are finding weird errors, cryptic errors, there have been a few breaking changes in Treesita recently, so if you just run ts updates, it's going to update all of your parsers, and then hopefully once you restart Neovim and reopen the help page for vim.lsp.start, you should no longer get any errors, fingers crossed. So this function is going to start our language server, and we are going to provide a path to this language server using this CMD over here. And that's it. We don't have to do anything else apart from this. So let's try this. I'm going to copy over this snippet from the help page, but don't worry, we are going to be trimming it down quite a bit so you don't have to copy this yourself. And in another terminal, I'm going to open up myinit.lua, and just for the sake of testing, let's paste down this code snippet. So every time we launch Neovim, we are going to attempt to run and start an LSP server. Now over in the name, first of all, I'd love to change these to double quotation marks. That's just my preferred style. And in between these, we can give a name to our language server. So I'm just going to do the most boring thing, and I'm going to call the language server clangd. Now in the CMD, this is where things get very important and interesting, right? Because we need this path that we copied over a while back with our clangd installation, and we need to paste it in here. And of course, we don't want to just provide the directory name, we want to provide the actual binary name, so clangd as well. And this is where it might differ from operating system to operating system. On Linux, this path is pretty familiar to anybody who's used Linux before, but on Windows, this is probably going to be C users, your username /desktop/clangd, and then the rest of the path. Note that if your clangd installation is, for example, clangd.exe, then you should also add the .exe at the end here. And then down at the bottom, we have this root directory. Root directory is pretty self-explanatory when you think about how programming languages work. Usually programming languages have a concept of a project. A project is a directory where you can store many different files. They can all import each other, include each other, and that's how you generally build big applications, by creating projects in programming languages. This root directory is supposed to be some sort of directory that the LSP should treat as the project root, and this is the root directory. This code, I'm not going to explain it all in this episode, mostly because these functions aren't actually in the stable release of Neovim. I'm not going to explain any of these yet because, you know, they might change or something. The gist of it is we are looking for a pyproject.toml or a setup.py. Now, this example that's given in the help pages is for Python, as you can see, because pyproject, right, and setup.py are both usually files that denote the root of a project in Python. We don't need any of these because we just want to try out whether the language server even works. So we're only going to be testing it on a single file. We can completely delete all of this, and we can type vim.fn.getcwd, which is going to get the current working directory which Neovim is in. You can see the current working directory either by running echo getcwd or by just running the pwd command, which does the exact same thing. So make sure all of the commands are set up appropriately, save and quit this file, and I recommend creating an empty directory, which I just called empty, and in here we can create a test.c file. And inside of this test.c file we can have the most basic C program there is. I'm simply defining a main function and then I'm printing hello world to the screen. But what you might have noticed is, hang on, I don't see any LSP completions, I don't see anything. Did it not work? Let's revisit our configuration. Okay, everything seems like it's fine, so why is it that when I enter a test.c file, I'm not getting any sort of diagnostics? Well, this is because of a quirk in the LSP client. If you start the client too quickly, it's not going to function the way you would expect it to. So what we have to do is we have to delay the execution of this start function by a little bit. And we can do this using an auto command. If you'd like to see what auto commands are, you can look at the help page, :h auto command, and it's going to give you a full-on introduction. Auto commands are essentially callbacks that Neovim broadcasts throughout the entire editor whenever some sort of event occurs. Now, there are many different events within Neovim, and if you run :h events, you can get the whole list of events that Neovim can broadcast when something about the editor changes. And as you can see, there are a ton of these. I can keep scrolling, and it will be a while before we hit the end. So what we want to do is we want to hook into one of these auto commands. We want to listen in on one of them. Now, the one we're specifically interested in is the one close to the top, the third entry down as of the making of this video. It is buff enter. Buff enter, you can see the description here. It occurs after entering, visiting, or switching to a new or existing buffer. Useful for setting file type options. So what we can do is we can say whenever we enter a file, and only after we have entered a file and after Neovim has fully loaded this file, do we actually want to start up our LSP client. Because when we do it over here, we are doing it before Neovim gets the chance to load all files into memory and load all of the buffers. So we're going to use vim.api.nvim_create_auto command, and we're going to listen in to the buff enter event. Now, after this buff enter, we need to provide a table, and inside of this table we can provide many types of metadata for Neovim, but we're specifically interested in the callback. And callback is a function that is going to execute once this buff enter event is encountered. So after Neovim loads the first file, which in our case is going to be test.c, it's going to broadcast this event saying, oh, okay, I've loaded this file. I'm going to now tell everybody I've entered a buffer. And now we can execute this callback to do something after we've entered this buffer. And we simply want to delete and paste over the code here. So after we've entered a file, we want to run vim.lsp.start. Now we can save, we can go back to the other Neovim instance which has test.c open, save and quit, re-enter the file, and would you look at that? If you've provided all of your paths correctly, you should see this error. And this error occurs because printf is not a known function. But look at that, we've just done something quite incredible. We've manually started up a language server. Now here are some really cool things we can do right out of the gate. The first one is we can hover over the function using vim.lsp.buf.hover. If you hit enter, you can see we get a window which shows us it's a function that returns an int. If I just include standard io.h up at the top here, I can also run this hover function over printf, and it's going to give me the whole description of this function. So I extracted the printf out into a function called sayHello, and now over here I can run this function, which is vim.lsp.buf.definition. And if I hit enter on here, you can see my cursor now moves from here to the definition of the function, which is in this case sayHello. So we have all of the features that you would expect from a big editor like VS Code or Eclipse by using our own fingers and by typing out some code which automatically starts the LSP server over here upon entering a buffer. We now have access to all of those features. And in fact, if you look inside of vim.lsp.buf, you have quite a lot of functions over here at your disposal that you can play around with if you would like to. All of these functions have help pages, so you can check them out and see what they do. And all of this stuff works in real time, so if I remove a character here, it's now telling me there's a call to some undeclared function, sayHello. But you see, this is quite problematic, isn't it? Because we had to do all of this to start up an LSP server. Now granted, it's not actually that complicated. As long as you know the path, your LSP server, you're actually fine. But it gets a bit more complicated. What if you want to configure the LSP server in some way? You want to change its settings and so on. Now you have to start playing around a bit with all of the different inbuilt options, and it gets a bit complicated. Instead of doing all of this every single time, we can have a plugin that does this for us. Not to mention, this buffer enter doesn't do any filtering. It's going to run this command on any sort of file we will ever enter, even files that are not from the C programming language. This is going to run clangd for every single file, no matter whether it's a C file or not. We would like to be able to filter out this stuff and only run clangd whenever we are within a C file, or only run a specific language server for a specific language. And this is where nvim-lspconfig comes into play. It is a set of quick start configurations for the Neovim LSP. And if you scroll down a bit, you can see what it allows us to do is actually quite useful. It allows us to simply run lspconfig.ourlanguageserver.setup, and that's it. So instead of going through all of the hassle that we were going through here, manually starting up this server, we can simply do lspconfig.clangd.setup. And that's the equivalent of all of this work. And not only that, nvim-lspconfig will only launch that language server if you're in a file for that specific language. Also, this root directory detection is going to be different for every language as well. Like if you recall, the example we saw was for Python specifically. So nvim-lspconfig has all of these configurations set up for you, so you don't have to do anything. So let us delete this code that was in our init.lua, and let's now set up automatic LSPs. We can exit out of the test.c file. We can also remove this file now completely. It doesn't matter whatsoever. So let's hop on over into our plugins.lua file. And inside of here, we are now going to declare a new plugin. So you should hopefully know the drill by now. We're going to create a new empty table. And within this table, we are going to take the end part of the URL, which is neovim/nvim-lspconfig, and we're going to paste it in over here. And also, before I forget, you are also free to delete the zip file as well as the directory that we unpacked clangd in. So over here, remove clangd and also remove the clangd zip. We're not going to need that anymore in this episode. So here we are setting neovim/nvim-lspconfig, and we want to supply some sort of configuration for this plugin. That makes sense because we are going to want to tell lspconfig what sort of LSP servers we would like to set up. In the suggested configuration, you see that this is what it's telling us to do. It's telling us to require lspconfig, and then after that simply run lspconfig.ourserver.setup. So let's do that. Let's declare a variable which we are going to call lspconfig, and we are going to require lspconfig in, and let's run lspconfig.clangd.setup. Now note, we deleted that custom installation of clangd. So what we're going to have to do, and this is some homework for you, is to set up the clangd server globally on your system. So you install it using the install instructions on the website. And then when it's available globally within your system, you'll know it's available globally because in a terminal of your choice, you should be able to just run clangd on its own without having to supply any sort of file path. If you can achieve that, if your terminal can see it, lspconfig can see it as well. The next thing that we need to do is we need to save, we need to quit, re-enter Neovim, let lazy install lspconfig for us, and what we've achieved here is exactly the same as what we did earlier manually. Now, as you saw, I have clangd installed because my shell recognizes that there is a clangd command. So what I should be able to do is I should be able to enter a random test.c file anywhere, type out hello world, and the second I hit escape, I should indeed have a fully working language server. I'm going to leave the episode here. There is still a ton that we have to go through, namely keybinds and also automatic installation of language servers. The homework that I gave you to install clangd is basically optional. Don't worry if you have errors when installing clangd or if something doesn't go your way. In the next episode, we are going to look at Mason. Now, the job of Mason is to automate the installation of these language servers so we don't have to do it ourselves. However, you can now go ahead and install any sort of language server that you would like. If you would like to see what sort of language servers are available for what language, if you scroll down in the nvim-lspconfig repository, there is a server configurations.md file, and this is a massive long file that describes every language server that is available. And usually these language servers are named after the language that they're designed for. So if I wanted a language server for Rust, I could search Rust, and indeed there is Rust Analyzer. If I wanted something for TypeScript, in that case it's called TS server, right? If I wanted something for Zig, there is ZLS, Zig language server. So you can now find your favorite language, install the language server for that specific programming language of your choice, and then go over here. If I wanted to set up something like the OCaml language server, if I just click on that, it's going to take me to the entry for it, and the snippet to enable the language server is right here, ocaml.ls.setup. So you can go down here into your config, lsp.config, paste in the name, .setup. Save, enter your favorite languages file, and you should have an LSP working for that language. I hope that all of these explanations made sense in this video. We are going to, as I said, continue the LSP journey in the next episode, where we're going to set up key bindings, and that is going to allow us to go to definition by just pressing some keys instead of running the long vim.lsp.buf definition function. And after we're done with that, we are going to set up Mason, which is going to automate the installation of all of our language servers, so we don't have to go over to these websites and look at every single installation instruction manually. Thank you so much for watching, and I will see you in the next episode. Ciao!